Understanding Earth processes is very important, not just to forecast extreme events in a timely manner, but also to better understand the interaction of natural and human systems and their effect on the availability of resources like energy, food, and water. The challenge is that Earth systems are complex and interconnected, whereas the data we currently have about them is not. How can artificial intelligence be used to integrate information, build models, and better understand Earth systems? Join us as we speak with Yolanda Gill and Suzanne Pierce, two of the authors of a research agenda on intelligent systems for geosciences.
Earth systems affect everyone. There's flooding, hurricanes, storms, earthquakes, volcanic eruptions. These are things that most of us recognize as part of the Earth processes that impact our world and our day-to-day living. But besides these short-term extreme events, there are also long-term planning implications that we need to understand better. Things like the kinds of energy portfolios that are best for the place where we live are most efficient, the water availability and scarcity, what are the kinds of crops that we can grow in the places where we live. All of these problems that are both of short and long-term duration are complex and interconnected. To understand them, we need computational power. High-performance computing is certainly part of the answer to the problem, but the really big challenge comes in the form of knowledge integration.
Earth processes are very, very complex, and we have a tiny, tiny sample of data compared to how much data we would really need to understand them fully. The data is also very different, very disparate. It's very hard to integrate. You have to know a lot about many disciplines to be able to understand how to pull it all together. And then also you need to understand causality in science. You need to have explanatory models. It's not just models that tell you if you like this movie, you'll like this other movie. It's more about why you really have this variable affected if some other variable changes.
All understanding is based on data, but when it comes to Earth science data, it is simply not feasible to collect everything. Instead, what is needed is a better strategy in data collection.
As geoscientists, we would like to have information about every single Earth process at every single place and every single time across the planet. We realize that's not a realistic expectation, so we've got to be selective about what we collect, when we collect it, how we collect it, and how we assure that it's discoverable for use after the first collection time frame. In order to do that, we need assistance in collecting data more intelligently, quickly, and effectively.
When AI systems have knowledge about the sensors and the models that they're thinking about, then they can redirect sensors. So the AI system can realize something new is happening, so I should accelerate the collection rate. Or it might understand that it needs to redirect a camera to another place where something more interesting is happening. Or sometimes we use AI to figure out how to optimize sensor placement. That's another very important aspect of understanding what kind of data to collect using knowledge about sensors and models.
The next important step, and a big challenge for AI, is to integrate the data with existing scientific knowledge in machine learning methods.
If you use knowledge to constrain a machine learning method, then what you're learning is much more accurate because it respects the physics knowledge that you have included in the learning method. So this is very important. And the other reason is that then your machine learning models will be more explanatory, because you can put the model in the context of the scientific knowledge, what is known already, and so you can add to it with new knowledge that comes from learning from the data.
The combination of geoscientific knowledge together with the advanced IS applications and approaches is where we'll start to see the breakthrough performance and outcomes. So research in intelligent systems and geosciences can transform our understanding not only of how we live today and how we interact with the Earth today, but more importantly, how are we going to interact and behave and manage our resources in the future?
there's many opportunities for AI research in planning and process composition, many opportunities for data integration, many opportunities for collaboration and combining human intelligence and artificial intelligence. There's many opportunities for robotics. So I think that if we look at science as a challenge for AI, it's very exciting that we can help AI advance, but also we can help accelerate scientific discoveries.
Learn more in the review article, Intelligent Systems for Geosciences, an Essential Research Agenda, in the January 2019 Communications of the ACM.